doing anything. It's all online.
Okay, we're live.
Perfect.
Okay. Let's go to part 1. Question 1. Pick from the list of graphs below. Which graphs can you use to describe categorical data? What were you guys' answers?
Pie charts and bar charts.
Bar charts.
Yeah, pies and bars.
Okay, and then this next one, when given a sample, what is the formula to compute the P bar type thing? Explain which each variable stands for in your formula.
Right.
So what I got was it's the P bar thing equals X over N, and then the N is the sample size and X is the number of individuals or whatever.
Yep.
Yeah.
Or the people that actually was either positive or negative, or depending on the, I guess the what wants to be solved. So
Yeah, the ones we're focusing on. Huh?
Yep.
The one thing I have a question right there is what the P bar is. The P hat, I mean. P hat. It's just the difference between the P and the P hat. One total and one's not. One you're focusing on.
It's kind of like with like the other statistics where there's like the mean of the sample and then there's the population mean. And so normal P is essentially like the population mean, and then the P bar is just the mean of the sample.
Okay, that's right. Okay, that makes sense. I thought of N in terms of just all the pieces. Maybe that seems to make sense, but I mean, it seems like a pretty simple equation when we've used millions of times in the past, but okay.
Yeah.
all right, then we'll go to question 3 then.
Yep.
Yeah.
Now, what is the mean of the sampling distribution of the samples proportion P? State the answer in words, not just a symbol.
That's the
Population proportion.
Yeah.
Yep. I think it's pretty straightforward. So.
Yep.
Yep.
Yeah, so the next one, what is the standard deviation of the sampling distribution of samples proportion? You may state this answer in symbols. Please include what each symbol in your formula stands for.
It's P quotations 1 minus P over N, all under the square root.
Yep.
And the P is the true population proportion. The N is the sample size.
Yep.
Yep.
Okay. Yep. That one.
Okay, 3, or not 3, but the next one. What is the difference between categorical and quantitative data? What are a couple of examples of categorical data?
So categorical is basically just studies into categories. It doesn't really have anything to do with numbers.
Yeah, I just think of it as like non-numerical. Like either yes, no, or a specific answer. So
yeah,
I just thought of the categorical as just stuff like gender, race, eye color, ice cream, state, whatever, and then you got the numbers. I like that one of the guys on the video said that quantitative is more like it's something you can do arithmetic with. If you can multiply it by 2, it's quantitative.
yeah.
Otherwise, it's categorical. I thought that was a good thought.
Okay, well, we go to part 2 then.
yeah.
Okay, open the file class survey using the file format for your class. Create a pie chart for class rank. Label it. Post it here.
So there's just 2
So
charts.
at first, this was annoying. Then what did you guys use to change
I use
the
Excel.
Yeah.
Yep.
Just total those numbers for each class, realizing that there are two that don't have a class they're assigned to, which was kind of odd, but make a pie chart out of it. But at first you had to do that, make the little charts you can do with them.
Yeah, I ended up using like the countif function and then turning that into a percentage or
Yeah.
So.
That's from our other class.
All right. Well, each of ours is probably similar. I mean, the next one is create a bar graph for the class rank, which is same process, and then the next one is, or 8 is, show at least 5 ways, graphs, and numerical statistics to describe the data above. So, I guess which 5 did you guys do?
Well, there's just the formula that, like freshman is 8 over 1 and 83, and that gives you the 0.0437.
Mm-hmm.
So the 0.0437 would be the p hat. Is that what they call it, p hat?
Yeah, I think it's p hat.
I thought they were saying HUD at first.
Well, should we go to what is it? Okay, so question 9, 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. The 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8%, in the survey use only cell phones? So then question A is, what is the mean and standard deviation of the sampling distribution based on 750 telephone users?
The mean is 7%, and then the standard deviation is 0.0093.
Mm-hmm.
Yep.
Right.
That's what I got. And then B, what is the z-score you would use? I got 1.073.
Yep.
Yep.
And I came up with 1.075 the second time I worked it, but there wasn't a 0.08 minus 0.07 divided by the standard deviation, which is 0.0093. It comes out 1.075. Is that what you guys got? No?
Well, it should be, I think,
The other way around.
0.07 parentheses 1 minus 0.07 all over. No, wait. Look at the formula again.
Yeah, that's right, isn't it? So it's
It would be
0.07.
0.093, and you have it under.
Because the standard deviation was 0.0093. That's the whole denominator. And the numerator was just for some reason I wrote down 0.08 minus 0.07. Is that how you guys figured it?
Yeah, 0.01. But then what did you divide it by?
The 0.0093.
Yeah, that should be it.
Yeah, which gives you the
5. Must be something around there.
Yeah, you know what? When I calculate it,
When you plug that z-score in, it comes out okay. Normal probability. That was the area 1412. Although the answer thing said 1416. I wondered if I was missing part of this part 2, to be honest with you, because two is going on and on past this about other stuff.
Okay, I mean it's 0.08 minus 0.07, and that is all divided by the 0.01 or that 0.0093. Yeah.
0.075. Is your z-score then?
Yeah.
Yeah,
One,
that's the thing I got too, is 1.075.
A little different than the answer thing, but
Well, maybe with the calculation, because with the standard deviation, I'm assuming that was rounded. And with that rounding, that could drastically change.
just a couple decimal places could change it to the 0.073.
Mhm.
So
yeah, that was 0.07, 0.93, which is p minus 1 divided by 750. Was that the square root of that? No. 9316652. So it could have, the rounding.
16652. So now I'm gonna see what that looks like.
if you do, if it's 0.01 divided by 0.009316, whatever, 1.073.
Yeah. So Garth and I, we just need to make sure to not use the rounded answer from previous questions to formulate the new formulas. We have to keep the original ones.
Yep. Exactly. That comes out 1.0733. Huh? That was a good point, Dan. Appreciate that.
Was there any other questions before we end the broadcast then?
No.
Nope.
It's going to be 0.1416, I think.
What's the probability that more than 60% of the survey use only cell phones, right? 0.08.
So you just compare the.
So you use the normal probability applet and you plug in the z-score, and since he's saying it's more than that, you'll shade in the right side. When you shade the right side of the applet, it'll be 0.1416.
Yep. Especially if you put in the right z-score like they didn't.
Yeah.
15, 16, perfect. Okay, gotcha. Perfect.
All right, we'll go to the quiz then.
Yep.
Yeah.